Welcome to 6.1, perpendicular and angle bisectors. So what's special about angle bisectors and perpendicular lines? Well, if you have perpendicular lines, then any point that is on the perpendicular line is equidistant to the points on the lines, specifically the endpoints. Okay, so here you have a segment here and you have a perpendicular line. All right, so the converse says this. If there's a point that is equidistant to the endpoints, then that means that point, point D here, has to be on the perpendicular bisector. That's why they didn't draw it connecting it. You can assume now that it is on that perpendicular bisector because it's equidistant to the ends. All right, now angle bisector, if a point lies on the bisector of the angle, then it's equidistant to the two sides of the angle. Now, be careful. Equidistant meaning the shortest path to that line, which would be a perpendicular line. So if I draw something different, it's not, this line right here is not going to be equidistant to BD. That's ridiculous. Nor that one, nor the next one. Okay? So none of those are equidistant. They have to be the perpendicular bisector. The perpendicular, not the perpendicular bisector. Okay, here's your angle bisector. You see you have two angles there. So any point on the on the angle bisector is equidistant to the sides of the angle. Okay, so then therefore you can say, hey, those two are congruent to each other. Okay, and then we go to the next one. The converse is if you have a line that's in your angle, AD here, and that point is shown to be equidistant from the angles, then you know this is these two angles are congruent. So you could mark them as congruent to each other. All right, so let's do some problems. Tell whether the information in the following figures allows you to conclude that point P lies on the perpendicular bisector. Okay, and then explain your reasoning. You have to give a reason why. Okay, so is point P on the perpendicular bisector? Okay, so first of all, it is on a perpendicular line. So for instance, if we had a line right here and said that's perpendicular and said, hey, there's point P, and all you looked at was the perpendicular part, you say, yeah, it's on the perpendicular bisector. Well, obviously, it's not on the perpendicular bisector if this was the case. All right. So what we want to do is show that this is the perpendicular bisector. Bisector meaning every point is equidistant to the endpoints of the segment. So n is equidistant to the endpoints. So therefore, every point that's on here has to be on the perpendicular bisector. All right. So yes, there's enough information, and because so instead of saying it all a second time, there's the answer, which is what I said. N's equidistant from the endpoints. Blah 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 blah. Okay, so 3. Is there enough information to say that point P is on the perpendicular bisector? Well, you don't know that this is perpendicular, right? Nor do you know that PM is P is equidistant to the endpoints. You know these two things. You don't know you have 90 degrees. So, and you don't have these pieces. All right. There's nothing to say that this is 90 degrees. It looks like it is, but you can't say it. And you can't prove that these two triangles are congruent. And then you could say by CP/CTC, these two are congruent. But there's not enough information here. It looks like it is, but you can't say it. So no is the answer there. Okay. Find the indicated measure, explain your reasoning. Okay, so now we're going to find the measurement. All right, so what are we trying to find here? We're trying to find GH. Notice there's no segment bar above it, so that means we're finding a value. It's an equal, not a congruence thing. So GH is right here. Well, because we know that 3.6 and 3.6, those are the same, so since those are congruent, point K is equidistant to the endpoints. And this is a perpendicular line, so that means everything on the perpendicular line here, everything on this line is equidistant to the endpoints, including point H. So point H has to be equidistant to both sides. Therefore, GH must be 4.6. Okay? All right, number 7. And we're looking for AB. So what does AB equal? So AB is this line right here. Well, because D is equidistant to the endpoints, that means this is a perpendicular bisector here. We have the 90 degrees there. That means B is also on the perpendicular bisector and is equidistant to the endpoints. So if it's equidistant, that means 5x is equal to 4x plus 3. They're equal to each other. So we subtract 4x and get x equals 3. Now that's what x equals. You have to find AB, so you have to plug it back in to what AB is. AB is 5x, so 5 times 3 is 15. And there's the long answer, basically what I just said. All right, let's move on to number 9. Tell whether the information in the figure allows you to conclude that the ray EH is a bisector of angle FEG. Okay, so you have H is on this line, this ray, but does that mean that these two angles are the same? Well, if H is equidistant, perpendicular to the sides of the angle, and we have that they're equidistant and it's perpendicular, we can then say, yes, these two angles are congruent to each other. Okay, so we could then mark those. All right, so let's look at the long answer I just gave. Okay, yes, because H is equidistant from EF and EG, so EH bisects the angle. That's the angle bisector theorem. Okay. Number 11, tell whether the information in the figure allows you to conclude that DB is equal to DC. So notice we have, distances here. Can we conclude that DB is equidistant? Well, we have the converse to the angle bisector theorem. We have an angle bisector here. These two angles are the same, so this is an angle bisector. So point D has to be equidistant to the sides of the triangle. Okay. Now the question is are these perpendicular? And since we can't show that they're perpendicular, you don't know really, let me draw it another way. You have no idea, this may be a bisector, but you don't know if point B is here and we could put C here or there. You just don't know where these points really are. You just can't randomly say, yeah, they're equidistant. But if it had the perpendicular line, then you could say yes. So the answer is no. Okay. Number 13. Find the indicated measure and explain. Okay, ABD. So ABD. We want the big angle here. Well, the angle bisector theorem says if a point is equidistant to the sides and perpendicular to the sides of the angle, then point D lies on the angle bisector, which means these two angles are the same. So if those two are the same, that's 20 and 20. So the whole angle, ABC, must equal 40 degrees. Number 15, FG. We want FG now. So we have perpendicular and we have angles that are the same. So this must be an angle bisector, which means x plus 11, FG, is equal to GH, 3x plus 1. So you have to set them equal to each other. X plus 11 equals 3x plus 1. And now just do algebra. I'm going to subtract to the right just because I like to have a positive x when I'm working. Don't have to. And then subtract 1, and we get 2x equals 10. Divide off the 2, and x equals 5. Again, they're not asking for x. They're asking for FG. FG is x plus 11. So now we substitute the 5 in, and we get 16. And there's the two answers if you want the formal answers. Number 17. What did they do wrong and correct it? You have to do both things. You can't just say what they did wrong. All right, so we have perpendicular here. A is between D and E perfectly, so this is a perpendicular bisector. The question is C on the perpendicular bisector? Well, the only way we know if C is on the perpendicular bisector is if C is equidistant from the endpoints. That's a perpendicular bisector theorem, the converse to the perpendicular bisector theorem. Okay, so what did they say? Because AD is equal to AE, AB will pass through point C. Well, no, we don't know that. We can't figure that out. Only if we knew that C was equidistant from D and E would we know that the perpendicular bisector passes through it. So we don't know it, and that's the explanation. Let me put what the book says. And there's basically what I just said. You just can't tell if it is. End of story. Correcting it, we just corrected it while we were saying that. All right. It may lie on the perpendicular bisector, but we don't have enough information, right? So just like in the previous chapter, we don't have enough information. Not enough information. Okay, write an equation of the perpendicular bisector of the segment with the given endpoints. All right, so right away, write an equation. So it's going to be a line. So y equals mx plus b is what our answer should look like. So we need the slope and the intersection of the perpendicular bisector. So perpendicular, if you remember, the slope of one line perpendicular to the slope of another line has to be the opposite sign and the reciprocal. Okay, so, and then we have bisector. That means we got to find midpoint. The midpoint, it remembers x plus x over 2 and y plus y over 2. Because the midpoint is where the perpendicular bisector is going to go through, and that gives us a point, an x and a y, that is on our new line. And we need the x and the y to solve our equations. Okay, first things first. Just to give you a visual, let's draw this. 1, 5 is m, and 7, negative 1, okay, is n. All right, so what's that slope? So the slope of m to n, you can subtract or you could do rise over run. Okay, so 5 minus a negative 1 over 1 minus 7 is 6 over negative 6, or negative 1. So that's that slope. So what's the perpendicular slope? All right, perpendicular to negative 1 over 1 would be, again, positive 1 over 1 and the opposite sign. So it's a positive 1. Clean that up a little bit. Okay, so that's our new slope. So right off the bat, we have y equals 1x plus b. Now the only way to get b is if we know x and y. And our x and y is going to come from the midpoint of this. So I'm going to draw in yellow approximately where that's going to be. I just randomly drew it, so I got to make it halfway in between. Okay, so now we got to find the midpoint. Now we could just look at this and probably find it, and we also have to know the intercept. That'll be the last thing we do. So do this in order. Number 1, you find the slope of the other line. Number 2, get the perpendicular to it. Number 3, midpoint. What's the midpoint of mn? So x plus x. So x, 1, and 7. 1 plus 7, divide by 2. And 5 and negative 1. 5 plus negative 1 divided by 2. So our midpoint is 8 over 2, or 4, and 4 over 2, or 2. That's our midpoint, 4, 2, which is right there. I got lucky when I drew it. Well, that is our x and y, so that we can find b. Y equals 1x plus b. So we substitute the midpoint in, because the midpoint's on our line. Any point that is on our line is going to be going to work for x and y. Now I can draw it. It doesn't say we have to draw any of this stuff. So our new slope is 1. So up 1 and over 1. Up 1 and over 1. Up 1 over 1. Up 1 over 1. So there is actually what the line looks like, or down one, left one, down one, left one, down one, left one. So this just shows you that freehand is not the best way to go. That's what the line looks like. It is a perpendicular bisector there. But what is the equation? We substitute 4, 2 in for x and y. And we solve for b. 1 times 4 is 4, so we subtract 4, and we get b equals -2. So what's our equation? Y equals 1x, or you can just say x, minus 2, because b is -2. You can say plus -2, that's fine. And we were right. Look, it says it's y equals x minus 2. Okay, number 21, write an equation of the perpendicular bisector again. Okay, remember, 1, find the slope. Slope of our line, so, is 4 minus 8 and -3 minus 9. So I'm going the same direction each time, and y's are always on top. -4 over -12. That's a positive 1/3. So step 2 is what's the perpendicular? That would be a -3 over 1. So this is our new slope. Y equals -3x plus b. Step 3 is find the midpoint. The midpoint gives us our x and our y. So midpoint is x plus x, -3 plus 9 over 2, and 4 plus 8 over 2. That gives us 6 over 2 is 3, 12 over 2 is 6. That's our x and our y. And we're going to plug it into this equation. So y is 6, -3 times x plus b. Okay, so we have 6 equals -9 plus b. Add 9, and we get 15 equals b. And our equation should be y equals -3x plus 15. Visually speaking, if you feel comfortable, you can go on or just watch. -3, 4 is u, and 9, 8 is right here for v. There's our line. Our midpoint is at 3, 6, so 3 right here. There's our midpoint. Our slope is -3 over 1, so down 3, 1, 2, 3 over 1. 1, 2, 3 over 1. Or the opposite direction, 1, 2, 3 over 1. So I want to show you something here. So I'll move that down. I'm going to show you that our y-intercept is 15 here by doing the slope. So up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. What is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Look at that. So that is our line. It's equidistant to both endpoints. Perpendicular bisector. All right, next. All right, in the diagram, the road is perpendicular to the support beam. Okay, so we can mark that it's perpendicular. AB is congruent to CB, so we can mark those two. Can you conclude that AD is congruent to CD? And no, you cannot. Oh wait, yes you can. I'm sorry, yes you can. The converse to the perpendicular bisector theorem is that if you have a perpendicular bisector, so we have the perpendicular, which is 90 degrees, and we have a bisector because it shows that these two are congruent. Any point that is on that perpendicular bisector is congruent, or is equidistant to the endpoints. So yes, we can say that those two are congruent. And there is your perpendicular bisector theorem. 27, what's the value of x in the figure? Well, notice we have perpendicular line here from the ray, and it's equidistant to this perpendicular line. So since this point is equidistant to the lines, that means the ray must be an angle bisector. And if this is 90 degrees, then each of these must be 45. That means 3x minus 9 is equal to 45 degrees. So we add 9, 3x equals 54. Divide off the 3, and x is 18. Classify the triangle. All right, let's do the review. Make sure you can do it. It is equilateral. And if it's equilateral, it's also equiangular. So, but it says classify the triangle by its sides. So just by the sides, it's equilateral. By the angles here, acute, acute. Oh, we have a 90 degrees, so we say right. It's a right triangle. Okay. Find the indicated measure, explain your reasoning. Okay. Because we have these two angles being congruent, this ray QS, or SQ, ray SQ must be an angle bisector. And since these are perpendicular, that must mean that they are congruent to each other. So 6x must equal 3x plus 9. So we subtract 3x, get 3x equals 9, divide off the 3, x equals 3. Now it says find QP, not x. QP is 6x. So we have to substitute this in. Please don't forget to read what they want. So the answer is 18. Okay, there's the official answer. Good job, you're all done.